Hello friends, today we are going to discuss with a new chapter, Rotational Dynamics, which is a very first chapter of your 12th science, newly established syllabus of HSC. And this chapter is also very important according to NEET and JEE point of view. We are going to discuss all the topics covered in NCERT book. The lecture flow will be like this. सबसे पहले हम डिस्कस करेंगे सिस्टम ऑफ पार्टिकल्स, आफ्टर दैट रिजिड बॉडी एंड एक्सिस ऑफ रोटेशन, सेंटर ऑफ मास, हाउ टू फाइंड द सेंटर ऑफ मास of some system of particles and the properties of center of mass, moment of inertia, on which factor moment of inertia is depend, what is the significance of moment of inertia, radius of gyration and its significance, torque acting on the object, angular momentum and law of conservation of angular momentum, rolling motion, when the body is rolled on an inclined plane, how to determine its velocity and acceleration. For the moment of inertia, we are going to use parallel and perpendicular axis theorem to determine the moment of inertia for various axes. After that, finally we are going to discuss the application of moment of inertia. And keep in mind, this part is very important because if you observe the previous NEET and JEE question papers, one question is surely asked on this topic. Okay, so we'll start with the chapter. Before going inside to this chapter, you should know what do you mean by particle and what do you mean by system of particles. Particle means it is the point mass. जब आप पार्टिकल को पढ़ोगे तो फिजिक्स की लैंग्वेज में पार्टिकल इज नथिंग बट द पॉइंट मास, एक पॉइंट मास है which don't having a measurable physical quantities like length, breadth and height. एक ऐसा पॉइंट मास जिसे लेंथ, ब्रेथ, हाइट नहीं है, ऐसे पार्टिकल को हम, ऐसे पॉइंट मास को हम क्या बोलेंगे? पार्टिकल. बट दिस पार्टिकल this definition is not fulfilling all the condition of physics. For example, if you are taking the example of train, let the train is having 15 compartments. These 15 compartments, when moving from Mumbai to Delhi, at that time the whole train is going to consider as a particle, because while studying the motion of the train, we are considering the total distance covered by the train from Mumbai to Delhi. That's why train is considered to be particle. The train is huge one, but still we are considering it as a particle. Now the same train, when crossing the bridge, suppose this is the bridge and the train having 15 compartments, but they don't having the same size, each compartment has a different size. At that time taken by compartment to cross the bridge is different. That's why the whole train does not consider to be as a particle. At that time, how to consider each and every point of the train? Therefore, train is not considered as a particle. So it depends on the situation when we have to consider the particle or when not. Whenever the particle is moved from one point to another point in a straight line, then this motion is called as a linear motion. When the particle is moved from one point to another point in a straight line, then this motion is called as a linear motion. Keep in mind, linear motion, this word is strictly related to motion of particle. Sometimes while defining, we are directly using object, bodies, we are not guessing, but keep in mind, linear motion is strictly related to the particle. Now, system of particles. System of particles means when two or more than two particles comes together, we can say it is a system of particles. When two or more than two particles are come together, we will call it as a system of particles, or it is also called as an object or a body. All of you know objects may be solid, liquid and gas. If you consider the solid, the two atoms, if you consider the two atoms, they are having interatomic distance, and these two atoms are bonded together with the help of interatomic force or intermolecular force. Because of this intermolecular force, they are having certain shape. They are having a certain shape. So system of particle means what? The particle which are at a fixed distance. जैसे सॉलिड में पार्टिकल्स कुछ फिक्स डिस्टेंस पे होते हैं. पार्टिकल्स एट अ फिक्स डिस्टेंस मूविंग टुगेदर. जब हम उसको मूव करेंगे, पार्टिकल एट अ सर्टेन डिस्टेंस मूविंग टुगेदर by keeping this interatomic distance fixed, as well as all the particles is having same velocity, acceleration as well as displacement. So system of particles mean what? It is the collection of particles having a fixed distance. Collection of particles having a fixed distance, and those particles are moving by keeping the distance between them fixed, and all the particles is having same displacement, velocity and acceleration. This is system of particles. So whenever the system of particles arises, it means we are considering object or a body. Whenever the object or body is moving from one point to another point, then this motion is not a linear motion. When object is moving from one point to another point, then this motion is not called as a linear motion, but it is called as a translatory motion. We will discuss it later. First of all, before going to study the rotational motion, we have to study the rigid body. Rigid body means what? Already we discussed. In a solid or liquid, the atoms are bonded together with the help of interatomic force. And this interatomic force, because of this interatomic force, their distance is difficult to change. So some objects are there in which the distance between two particles is fixed. Distance between two particles is fixed, or interatomic distance or intermolecular distance is not changed even we are applying the force on it. जब हम ऑब्जेक्ट पे फोर्स अप्लाई करेंगे तो दो एटम्स और दो मॉलिक्यूल के बीच का डिस्टेंस चेंज नहीं होगा even we are applying the force on it. Such bodies are called as a rigid body. So rigid body means what? The body in which intermolecular distance or interatomic distance is fixed irrespective of force. Irrespective of force मतलब क्या हुआ कि हम कितना फोर्स उस पर अप्लाई करेगा ये मैटर नहीं कर रहा है वहाँ पे. Intermolecular and interatomic distance is fixed irrespective of application. Application of force is called as a rigid body. Topic is translatory motion. Already I discussed about it. Translatory motion is related to object or system of particles. It is not related to particle only. It is related to particles. So translatory motion, when system of particle moves in a straight line. System of particles moves in a straight line, then we can say the object is performing translational motion or translatory motion. At that time we are saying translational motion or translatory motion. For example, consider this is a pen. This pen is moving from this point to this point. Now this pen is having three particles located at these points as shown A, B, C. When you move those particles, the particle A comes to here, B comes to here, C comes to here. If you observe the displacement of each particle, then it is same. And while moving, acceleration, velocity of each particle is same. Such a kind of motion is called as a translational motion. So whenever the system of particles is moved in a straight line, then the motion is called as a translation motion. So all of you clarify the difference between linear motion and translational motion. Okay, linear motion is related to particle and translational motion is related to system of particles. Both are linear, but it is related to particle and it is related to object or system of particles. Now, the second thing, already we discussed linear motion, translational motion. Now I am going to discuss with circular motion. Circular motion, you observe it from 9th standard. The basic definition of circular motion is motion of particle along the circumference of circle is called as a circular motion. Motion of a particle along the circumference of circle is called as a circular motion. For example, suppose this is a particle and this particle moves in a circle. Then this is the center of the circular path and particle is moving along this path, which is circular one. If you consider the distance of particle from the center, then it is always remains constant. So circular motion के बारे में हम ये भी कह सकते हैं, particle का जो distance है from the fixed point, it is always fixed. The distance of particle is always fixed with respect to some fixed point. Such a kind of motion is called as a circular motion. Circular motion समझ में आया? Actual definition, very simple definition is motion of particle along the circumference of circle is called as a circular motion. And in another way, we can define it as the motion in which distance of particle is fixed. Distance of particle is always fixed from a fixed point. Such a motion is called as a circular motion, and this fixed point is nothing but center of circular path. Some related quantities for a circular motion is, first one is radius vector. Suppose particle is moving in a circular path. This is the center of circular path. Particle is initially at point A. Then the vector drawn from center of circle to the position of particle is called as a radius vector. Vector drawn from center of circle to the position of particle is called as a radius vector, which is denoted by r bar. After that, what do you mean by angular displacement? Suppose the particle at A comes to point B after time t. Particle performing circular motion is moved from point A to point B in time t. Then angle trace. This angle is trace and this angle trace is called as an angular displacement. So angular displacement is what? Angle traced by radius vector. ये radius vector, इस radius vector ने t टाइम में यहाँ पे ट्रैवलिंग किया, तो इस radius vector ने सेंटर पे जो एंगल ट्रेस किया है उसे हम बोलेंगे एंगुलर डिस्प्लेसमेंट. So how to prepare the definition? Angle traced by radius vector at the center of circular path. Angle traced by radius vector at the center of circular path in a given time at the center of circle is called as an angular displacement. Angle traced by radius vector at the center of circle in a given time is called as an angular displacement. All of you know the angle is measured in radian. That's why the SI unit is radian. Angular velocity. Suppose theta is the angle covered in time t, then this angle divided by time is called as a angular velocity, which is denoted by omega. So angular velocity को हम कैसे define करेंगे? Angle trace per unit time. Angle trace per unit time. देखो यहाँ पे angle trace per unit time is called as a angular velocity. और हम उसे ऐसे भी define कर सकते हैं, rate of change of angular displacement with respect to time. जैसे कि हम उसको ऐसे डिफाइन कर सकते हैं d theta upon dt, which is also called as a average angular velocity. What we will call it as a average angular velocity, which is defined as the rate of change of angular displacement with respect to time is called as a angular velocity. So angular velocity is angle upon time, that is omega is equals to theta upon d. Now the rotational motion. As we discussed, circular motion is related to particle only. Whenever the particle is performing circular path, then we will say it is the circular motion. But what is the difference between circular motion and rotational motion? Many people don't know. Some people are saying circular motion and rotational motion is one and same, but no. Circular motion and rotational motion are not the same things. जैसे कि हमने देखा कि linear motion particle से related है और translational motion, body से related. Similarly, circular motion related to particle and rotational motion is related to system of particles. Let's take an example. Suppose this is the ball. This ball is rotating or circulating or what do we say? Whether this ball is performing circular motion or rotational motion? Yes, good. Rotational motion. Why? See here, this spherical ball consists of large number of particles, and if you are taking the example of this particle, while rotating, this particle is performing circular motion. See carefully. Suppose this is the particle. This particle is also performing circular motion. So, ultimately all the particles on this object or on this spherical ball is performing circular motion. And as the question is arises, if those particles are performing circular motion, where is the center of those circles? Those circles are lies inside, those centers are lies inside the sphere. And if you consider those centers, then all those centers are lie on the same straight line. For example, see here. Suppose this is the sphere. Suppose this is the sphere. Here it is the particle. This particle is moving in a circular path like this. Again, this is the particle of this sphere. This particle is again moving in a spherical path, circular path. This is the particle, this is again moving in a spherical path. Now, all the circles are having different centers. But what is the speciality? If we join those centers, all centers are lies on the same axis, and this axis is called as an axis of rotation. So, what do we see in a rotational motion? Let we are considered three particles ABC. Those all particles are performing circular motion, and this circular motion, ये particles की जो circular motion है, I am not saying particle, I am saying particles, plural. ये जो particles की circular motion है, this circular motion is called as rotational motion. So when system of particles is performing a circular motion, about the same axis or about the same point, then the motion is called as a rotational motion. System of particles. When the system of particles are performing circular motion about the common axis or common point, then the motion is said to be rotational motion. Now, during the rotational motion, all the centers, already I discussed, during the rotational motion, all the centers of the circular paths of all particles is lie on the same straight line. इसका मीनिंग क्या हुआ कि जो भी पार्टिकल्स है वो पार्टिकल सर्कुलर मोशन परफॉर्म कर रहे हैं, जो सर्कल्स बने उनके जो सेंटर्स है, all those centers are lie on a same straight line. During rotational motion, the center of all the particles, the centers of all the circular paths of particles are lies on a same straight line. Is it clear? So keep in mind, circular motion is related to particle and rotational motion is related to system of particles. After that, a rolling motion. देखो हमने अभी तक लीनियर मोशन देखा, ट्रांसलेशनल मोशन देखा, उसके बाद रोटेशनल मोशन देखा. अब हम देखने जा रहे हैं रोलिंग मोशन. क्या है रोलिंग मोशन? आपने नाम तो सुना होगा. Let's take an example of wheel of cycle. देखो अभी सपोज ये व्हील है, यहाँ पे मैंने ऑलरेडी डिस्कस किया है. If you consider this wheel is moving on a horizontal ground. At the time of motion, this A point, suppose consider half rotation is already done. In a half rotation, what you observe, the center of the wheel, let's say it has O, this center of the wheel is moving in a straight line. That is, the center of wheel is performing linear motion because O is the particle. Center, we consider it as suppose particle. So this particle is performing linear motion. And if you consider the point A, after half revolution, this point A is at bottom. After that, C is comes to here, and B is, which is initially at bottom, which comes at the top. So it means A, B, C, those particles are performing rotational motion and point E is performing linear motion. So it is a combination of rotational motion and linear motion. So such a kind of motion is called as a rolling motion. So rolling motion is nothing but the combination of rotational motion and translational motion. Getting? Rolling motion is the combination of translational motion and rotational motion. If you are taking the example of vehicle, at that time the wheel of vehicle, center of wheel is moving in a straight line, but the other particles are performing rotational motion. तो ये कॉम्बिनेशन हो गया लीनियर मोशन का एंड रोटेशनल मोशन का. तो इस कॉम्बिनेशन को हम बोलेंगे रोलिंग मोशन. सो रोलिंग मोशन इज नथिंग बट द कॉम्बिनेशन ऑफ रोटेशनल मोशन एंड linear motion or translational motion.